Hi, it's me, Paula, the math tutor. And in this video, we are going to formally define binomial distribution. For this, we are going to define what it means for a variable to be binomially distributed, how you can recognize if a variable is binomially distributed, and then we're going to see how you can calculate the probability of a variable taking a certain value if it's binomially distributed using technology. Let's begin. In the last video of this series, we discussed how to get to calculate the probability of something binomial happening a certain amount of times. If you haven't seen that video yet, you can go back and see it. But we got to this formula. We have that the probability of a variable x takes a certain value, it's going to be combinations of the number of trials this is happening, choose the number of successes we are expecting, times the probability of success to the power of the number of successes, times the probability of failure to the power of the number of failures we are expecting. And that is the total number of trials minus the number of successes. The probability distribution for this variable, if it's actually representing a binomial situation, it's called binomial distribution. And this is how we are going to write it. To study a binomial situation or to discuss a binomial distribution, what we need to know is the number of trials and the probability of success. So the probability distribution of this variable is defined by n, the number of trials, and p, the probability of success. Let's discuss what needs to happen for a variable to be binomially distributed. There are 4 conditions we need to meet before we can consider a random variable to be binomial. First of all, we need what we call a binary situation. Something is binary if one thing can happen or another thing can happen, and that's it. We need to be able to treat all trials as either a success or a failure. Then we need the trials to be independent. The outcome of one trial can't affect the outcome of the trial after it. Then we need to know the number of trials. That n that defines the binomial distribution needs to be known and fixed from the start. And then we need to have the same probability. In each trial, the probability of success needs to be the same always. If you have those 4 conditions, then you can say a variable is binomially distributed. Think it as a checklist. If you find a variable, a discrete variable, and you want to see if it's binomial and you can use the binomial formula to calculate probabilities, it needs to meet those 4 conditions. Let's see some examples and analyze them to see if they're actually binomial or not. For example, each child from a particular set of parents has a probability of 0.25 of having type O blood. Suppose these parents have 5 children, and let's call x the number of children with type O blood. We want to know if x is a binomial random variable. Let's see if it meets all the conditions. First, it needs to be binary. And yes, it is. The child either has type O blood or it doesn't. We can classify this as success or failure. And success and failure is not something you measure morally. It's just we can classify as it happens or it doesn't happen. That's what we mean with success or failure. Then we need the trials to be independent. And in this case, well, yes, the fact that their older sibling has a type of O blood is not going to affect a child having a type O blood. Then we need a fixed number of trials. And in this case, we know that they have 5 children. So we have our n, it's 5 and it's fixed from the beginning. And then we need the same probability for each trial. And we have it. It says that the probability is always 0.25. So we're meeting all the conditions. This variable is a binomial random variable. We will write it as x, it's distributed binomially with n equals 5 and p equals 0.25. Let's try another example. Let's say we flip a fair coin until it lands tails. And let's call g the number of times you flip it before it lands. Is g a binomial random variable? Let's see. Well, is it binary? Yes, it is. Each coin flip can either land in heads or tails. There's not another possibility. Are the trails independent? Well, yes. Flipping the coin one time is not affected by flipping the coin before. The outcome of one coin flip doesn't affect the probabilities of the next coin flip. Then, is the number known? No, it's not. Because it says that we're going to flip it until it lands tails, so we don't know how many times we're going to flip this coin. Meaning that this variable, it's not a binomial random variable. Let's calculate some binomial probabilities, but using technology. If you choose to use the formula of the binomial distribution, you'll see you have combinations and you have exponents, which means that doing this by hand is almost certainly not impossible, but extremely annoying. I don't think anyone is going to ever ask you to find a probability by hand. And for example, in the IB exams, I've never seen an exercise without a calculator where you need to find binomial probabilities. So either you choose to use the formula or you choose to use the binomial distribution functions that the calculator brings, you will always have a calculator in hand. Only if it's a super simple example and the probabilities are super simple, you could do this by hand easily. So in any case, you'll have the calculator with you. What we need to know for using the calculator, because this is a binomial distribution, is the number of trials, the probability of success, and the number of times you want to succeed in that total number of trials. So you're going to need p, you're going to need n, and you're going to need x. Your calculator has two functions. One, it's called binomial PDF, and the other one, it's called binomial CDF. Binomial PDF stands for probability distribution function. This means that we are calculating the probability for exactly one value. If you use that function, it's because you want to find the probability of a binomial random variable being equal to exactly something. But the other one, it's called binomial CDF, and the C stands for cumulative. That is useful for when, for example, you want to calculate the probability of a random variable, of a binomial random variable to be less than or equal to a number. Let's do some examples. Let's use the example about the types of blood. Let's say we want to calculate the probability of this couple having 3 of their 5 children with type O blood. In this case, then we have the total number is n, the probability of success is 0.25, and the number of successes I'm looking for is 3, exactly 3. I could use the formula. I could do combinations of 5 choose 3 times 0.25 to the power of 3 times 0.75 to the power of 5 minus 3, so to the power of 2. If I use the formula, I would try to calculate that. Or I can also use the function my calculator brings about binomial distributions. And I'm gonna show you where to look for in the TI-84, but if you have another calculator, it's probably somewhere similar. Here we are in the main screen. For distribution of random variables, I want to go on top of the vars key. I have something that says distributions. To activate that, I want to choose second, and that opens a bunch of options. We will use later some of them, but if I go down, I find the binomial options. And as I was saying, you have two, binompdf and binomcdf. The example we're analyzing says that we want the probability of 3 of the 5 children to have type O blood. So I'm going to open PDF because I want it to be exactly 3, no more, no less. So I'm going to press enter here. And now I have the numbers I have to write. Trials. This is the total number of trials I have, and in this case it's 5. Now the probability of success, 0.25. And now the x value, the number of successes I'm looking for, is 3. And this is going to paste the result in my main screen. I'm back on my main screen and I have now the numbers that define the binomial PDF function. If you're ever solving a problem in an exam, for example, and you want to justify that you used your calculator, you can write this and anyone correcting it will understand. And to get the result, I'm going to press enter. And there I have the answer. So the probability for this family to have 3 of their 5 children with type O blood is 0.08789. You can round it. This is it for this video. And this is the theory about binomial distribution we are going to discuss. In the next videos, we are going to try some examples, some style exercises. Bye bye.